Hello. Today we will be analyzing our second um, malware sample um, uh, in our course. Today we are analyzing um, the index.exe malware. Um, so I'll just quickly go through what I determined by statically analyzing the malware at first. Um, uh, yeah, was able to grab all the information that I needed from PE Bear, PE Studio, the hash of the file. Um, it is, let's see, I'll get to the floss output that I had. Um, this was a Windows Vista PE file. It's a 32-bit executable um, that was compiled on June 14th of 2023. Um, it is um, it is developed in C sharp um, or C++, not C sharp, sorry, and in the Microsoft Visual C C++ compiler. Um, File entropy is about a 6.3, so doesn't seem to be packed. Detected easy, didn't show any sort of packing. Grab the import hashes, the section hashes. There was a debug file with this exe with three debug streams, RSDS, PGO, and VC feature. Um, and I also noticed within PE Studio that there was a manifest that was embedded within this within this executable. Um, Same kind of thing as the last, and I had analyzed the DLL on the last recording. For this one, there was an overlay, but it basically, there was nothing really there. It was a very small amount of bytes. Um, in terms of, um, I don't want to spend too much time talking about the static analysis part, but um, I did notice a few interesting imports, specifically a lot of WinInet DLL activity, some write files, some delete files, some shell execution, virtual alloc. I also noticed this interesting one here, which has the ordinal of 680, which is user and admin. So just something I thought was noteworthy. There was no exports with this malware um, or with this file, and um, so when it came to strings, there were a few interesting things there. I saw there was a bunch of months, like I saw like January, February, March, April, May, potentially also some language abbreviations that I had come across, but really not much else. Yeah, there were some system calls as well. Um, I guess I'll quickly hop over to floss, like my floss output. Um, Floss had decoded the following strings, which I guess aren't really fully decoded. I guess maybe it thought it was something. Um, a lot of strings with the double equal sign at the end. I wasn't sure if that was some sort of like base 64 decoding, but I guess Floss would have decoded that anyway. But I, but this is kind of what the Floss output was. It was basically showing me a lot of these different strings here with these double equal signs. Um, and then of course just some like it says string too long, but yeah, I guess Floss wasn't too helpful in kind of decoding anything there. And that's basically kind of what I saw myself when I looked at some of the static strings. Um, so kind of going from my initial theory on just the static analysis, I had wrote that if I had to guess, I would say maybe another kind of first stage malware that's reaching out over the internet to potentially write a file to disk, maybe another kind of loader. Um, I mentioned the is user and admin activity, which I thought was suspicious, and I also saw that there was is debugger present, so potentially some sort of evasion. Now that was my static analysis, my static hypothesis, but I think things kind of changed a little bit when I kind of went into my behavioral analysis and actually ran the malware. I saw different things that kind of gave me different theories about what was going on here with this. Um, so what am I at right now? 4 minutes. Okay, so um, first things first, let me pull up the VM, and I'm gonna show all the tools that I used here. 1 second. Okay, So System Informer we used Procmon, and we'll get into the Wireshark findings. Red shot, where's my red shot? Yeah, okay. So first things that I kind of wanted to talk about was red shot. Right, we ran our malware, we ran the index.exe, and uh, right, looking at kind of what registry keys may have changed apart from between the first and second shot, I noticed something really interesting, and uh, it's 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 concerning, right? If you know, from a malware analyst perspective, where is it specifically? Right here. So um, these are the deleted keys that Redshot detected, and they all seem to be device IDs for some sort of uh, external peripherals, um, right? Like, let's see if I can find. There's like keyboard driver packages. There's, if I can find it. There's so many. There's like thousands. Um, there was. I saw like chargers. I saw like laptop chargers, like computer chargers, like um, power supply drivers. I saw monitors, like for instance. Um, this seems to be some sort of NVIDIA RAID disks. But yeah, like all so many drivers that it was deleting the keys for, um, which I thought was very interesting. Let me see if I can find. Right here was a big one. I see there was a key added for a scheduled task to run this rugen.exe, which could be maybe a second stage malware that the index.exe pulled down. I quickly learned that that's not the case, but what else did I want to talk about in Red Shot? Those were the main things though in Red Shot within the 10-minute video here that really caught my eye was all those device key changes, and obviously that scheduled task that was created. So let me quickly look at the other two tools here. System Informer, when I ran it, I noticed that it kicked off a few processes. It ran commands, and I guess the process tree shows that, but I didn't really see too much too much notable activity within System Informer. Um, the main thing was I saw index.exe startup and then that rugen.exe startup. And then I terminated the process, and now I see the rugen is running um, from that scheduled task. So I'm confirming that uh, it did successfully kind of make it persistent, and that is now running in a scheduled task even after I terminated the actual user clicked exe that I had done. Um, we'll talk about the network stuff in a second. Um, this is great. Using Procmon and the process tree to kind of see what I had witnessed. Right, we see the index.exe get kicked off, and then rugen get kicked off um, in the scheduled task, and then in kind of doing some research here at looking at the arguments and commands that it ran that scheduled task with, it seems that it's running that rugen every minute. So if I were to terminate it, it would come back within 60 seconds. Um, so other things that were going on when running that index.exe, it seems that it's using this cackles command line tool or argument, which seems to change the access permissions of that rugen file. Um, it seems to change it to allow or maybe set owner or just permissions for the mal analyst, which is my user. Um, so kind of interesting. It seems that maybe it's, if I had to guess, making sure that because that rugen.exe is a scheduled task under my user, that my user can actually even run it in the first place. Um, so that was pretty interesting. Let's see, what else did I want to note there? I think that was the main thing, was just those cackles permissions changes, and the fact that it's a scheduled task. And then I was wondering, like, okay, is rugen, like, what is rugen? Like, where did this file come from? I ran a static analysis on rugen, and I realized that it's basically just index.exe, just renamed. It just kind of changes the name of itself, makes it so it is persistent, and just running it every minute. So I thought that was interesting, and I think that's where I think the static analysis definitely helped. I threw it in PE Studio, and I saw the hash was the same for both index.exe and rugen.exe. So that answered my question of, okay, is this a different file? Is this a different, is this the next level or next stage of the malware? Um, Next thing I wanted to kind of call out was look at my notes here, was the network side of things. So I had ran this with fake net, and if I pull up the log there, I see that Rugen is going out to this IP here, 77.91.68.63. And I see that it was doing a post request. So I took this IP and I searched for it in Wireshark on the packet capture from FakeNet. Not this one. Where am I? Oh, it was this one. Okay, yeah. Why is it showing this? Hold on. IP.adder equals. Oh, okay. Yeah. So um, right here. So a I'm seeing a post request to that weird IP, and it's posting to /doma/net index PHP. Now, I didn't really know what to think of that. It did a GET request first to confirm that it could reach it, and then once it got that response, it went ahead and made this post request. So I'm thinking maybe, hey, if it's actually making post requests, then maybe this is some sort of info stealer. Maybe it's sending data over, maybe sending data uh, via index PHP to this weird IP. Just some things I saw. It might be easier to know once we start doing some code analysis. Um, but yeah, that's kind of the main observations that I had. Let me just bring this back over here. Again, the main things was that we ran this. It renamed itself, created a scheduled task that would run, that would just keep running it every minute. It would change the permissions of that exe so that the mal analyst user, in my case here, has the permissions to actually run it. Um, we were able to see in the red shot that there was a bunch of weird activity going on with the device drivers and device IDs, that there was just deleting keys. We saw that that's where the scheduled task was set up. And yeah, and then we see that weird post requests to domain.net index.php. So again, I wrote maybe some sort of info stealer, maybe some sort of wiper if it's removing those device IDs. Maybe it's trying to like disconnect itself or something. So um, and when I say disconnect itself, like it's like removing all the external devices or something like that. Maybe to slow down analysis or something. Um, but yeah, that's my main analysis there. Um, and I will update the rest of the sheet and send it over to you. But hopefully, I think the main things hopefully I detected. So thank you, Anuj.